I'm Jennifer Cobbe, and I'm going to talk about understanding accountability in algorithmic supply chains. I'll explain what they are, describe their key features, and discuss some implications for algorithmic accountability, which we understand as a mechanism for challenging power and protecting people and societies. I'll argue that algorithmic accountability must attend to the dynamics of supply chains and the challenges they raise. Algorithmic accountability research increasingly seeks to understand the process of developing, deploying, and using algorithmic systems. This research has sought or proposed ways of understanding specific stages in the algorithmic lifecycle, such as for data sheets, model cards, and system cards, or to integrate such mechanisms into frameworks that work across the lifecycle, such as our own work on reviewability and work by others on auditability and traceability. This research has often reflected assumptions, implicit or otherwise, that the organisation developing an algorithmic system will be the one that deploys it. The tools which have been proposed are useful, but this focus on systems developed and deployed by single organisations is insufficient. In fact, production and distribution of algorithmic systems is often now organised around data-driven, algorithmic supply chains. In these, multiple actors contribute to and control different aspects of developing, deploying, using, and the functionality of AI technologies. This reflects the rise of cloud computing and the modular nature of computing resources distributed as services. Where developers might once have integrated components into a system controlled by them, they now delegate control over underlying technologies in supply chains to others. So, rather than a system, digital technologies often work through a system of systems, a data-driven supply chain in which outcomes and functionalities result from the working together of multiple actors and organisations. This could be hardware capabilities, software functionalities, commercial or industrial processes, AI decisions and outputs, and more. Supply chains are data-driven as the flow of data from actor to actor links systems and makes functionality possible. Component systems themselves have supply chains, producing complex chains of actors linked by data flows between systems they control. In this example diagram of an algorithmic supply chain, there is an input by the end user of the mobile application, which triggers data flows to an AI service with its own supply chains. The AI service's outputs then pass through several other actors before data finally comes back to the mobile application to produce some functionality for the end user. Algorithmic supply chains often involve AI services, where a provider offers access over the internet to models they control. These provide functionality that customers can integrate into their applications. Developing advanced AI technologies needs technical skills, resources, and data that many organizations lack, but AI service providers offer relatively easy access to powerful models at low cost. Bigger providers like Amazon, Microsoft, and Google offer numerous AI services across these categories. In some cases, they act as intermediaries through which smaller provider services can be accessed. Smaller providers themselves typically specialize in one or two specific kinds of technology, like facial recognition services or generative services. Several features of algorithmic supply chains challenge organization-focused approaches to accountability. First, the actors in supply chains are interdependent. One actor might produce datasets for system development. A second actor, an AI service provider, might produce the system using that data and offer it as a service. A third, the provider's customer, might then use that service, deploying the system in their application. A fourth, the application's end user, might then actually use that system in a particular context, sending data back to the provider for processing. So different aspects of production, deployment, and use of algorithmic systems are split between multiple actors linked by data flows. Each actor thus depends on the actions of others. They might not know about each other, but their interdependence means that the supply chain context is crucial for understanding these actors' activities and their role in the workings and effects of AI technologies. This also means that problems can cascade through supply chains quite easily. Because customers depend on a provider's system for functionality in their application, for example, biases in that system will be inherited by their application. So problems arising with one actor can propagate to others in a given chain in complex and unpredictable ways, as well as across the various chains where that actor operates. It's also important to note that interdependencies in supply chains are usually asymmetric. Certain actors are core players in supply chains because they do things that others disproportionately rely on. This produces asymmetric balances of power, which typically benefit those core actors. Second, supply chains are transient and dynamic. They come into existence when functionality is requested, and through the supply chain, there may be several directions for data to flow depending on the results of its processing. So the structure of supply chains and the actors involved may change each time they are instantiated, and may only be fully apparent once the outcome is being produced. That said, certain actors may have ongoing bilateral, legal, technical, or economic relationships. Third, as our previous research has shown, supply chains are increasingly consolidating around a few key actors, primarily Amazon, Microsoft, and Google, but also some others. These providers offer infrastructural and user-facing services across many markets and sectors, and they produce their own AI technologies and distribute them through those services. Together, they're the biggest players in the cloud infrastructure market and in AI services, and the technological requirements for developing state-of-the-art AI technologies mean their cloud services are crucial for many specialist providers. Even someone like OpenAI uses a major provider's infrastructure for production of their technologies and distributes them through that provider's interface. Some specialist providers use one cloud provider's infrastructure for development and other cloud providers for distribution. And even open source models will often run on a major provider's infrastructure. So, as well as being core actors in many supply chains, the major providers are also systemically important for the political economy, governance, and accountability of AI more generally. Together, the features of supply chains I have described raise important challenges for algorithmic accountability. A first challenge is the distributed responsibility in supply chains. Different actors control different aspects of production, deployment, and use of algorithmic systems. Not all actors in algorithmic supply chains are responsible for their outcomes. Some will only provide supporting services, nor will all actors who are responsible be equally responsible. Some will play bigger roles than others in determining outcomes. But responsibility for the workings and outcomes of supply chains is distributed, with no one actor in overall control. This means it's important to identify who is factually responsible for which aspects of supply chains and to allocate accountability based on a proper understanding of their dynamics. Because if you direct production-related accountability obligations to those responsible for deployment, for example, you won't get very far. A second significant challenge is the accountability horizon in data-driven supply chains, the point up or down the chain beyond which an actor cannot see, illustrated here in blue for actor A. Most actors in supply chains will know who they interact with directly. They may have some information about those another step away, but they'll often have no way of knowing about supply chains beyond that. And distributed responsibility means that they'll typically have incomplete information about aspects of production and deployment that they aren't responsible for. So those producing systems will lack information about customers' contexts and use cases for deployment, which makes problem framing difficult. And customers won't know whether producers have framed problems in relevant ways for what they want to do, which make choosing an appropriate AI service difficult for customers. Distributed responsibility and the accountability horizon together also potentially undermine risk management obligations in governance and accountability frameworks like the EU's AI Act and in data protection law. A third challenge is that providers often seek to leverage the distributed responsibilities and asymmetric interdependencies in supply chains to minimize their accountability obligations. They can outsource dataset production activities to jurisdictions with weak or non-existent privacy laws, data protection laws, workers' rights, and employment protections to minimize their legal and other accountability risks. They also leverage APIs and terms of service to extend control down supply chains past the point of deployment by customers, seeking to frame their activities and relationships in legally advantageous ways, trying to minimize liability for harms arising from their systems, and frustrating attempts to hold them to account for their role in production of AI technologies. Several things are needed to improve accountability in algorithmic supply chains. First, we need criteria for identifying the distribution of responsibilities between actors, particularly where certain actors are core to chains or systemically important more generally. We also need processes for allocating accountability accordingly for the right activities with the right consequences. Second, we need legal, organisational and technical mechanisms for expanding the accountability horizon, as we proposed in our work on decision provenance for tracking data flow through supply chains. Such mechanisms would help bring better understanding of the actors and interdependencies in supply chains, both for those within them and for those overseeing them. And third, we need interventions to limit providers' ability to extend supply chains across borders to exploit differences in laws. And we also need to restrict or condition their power to use APIs and terms of service to extend control over other supply chain actors. In all, if governance and accountability mechanisms are to properly contend with the algorithmic systems and AI technologies of the future, if people and societies are to be properly protected, then the dynamics of algorithmic supply chains must be properly understood and their implications for algorithmic accountability must be urgently addressed. Finally, here's a QR code that you can use to access our paper.